So this is period 6, and I want you to, well, first of all, this is period 6, and we're starting with the last question on the homework. I've already uploaded other videos explaining the previous questions on the homework. So we're just going to explain this one question, which is the last question on the homework. And after that, I hope you have the ability, the skills to graph the rest of them and answer the rest of them. So on the homework, question number 6, the last one on the back side of your notes from last week, you have this exponential growth function, y equals 3 times 2 to the x power minus 9. And we need to remember or memorize the form of an exponential growth function, or decay function for that matter. So kind of like back when we were graphing lines, y equals mx plus b was the slope-intercept form. That was the form that we used for graphing lines. This is the form that we're going to be using to graph exponential growth or decay functions. Not only are we graphing exponential growth or decay functions here in Algebra 1, but you're also going to be graphing them in Algebra 2. So I hope we remember from last week that step 1 to graphing exponential growth or decay function is to ignore h and k. Okay, so ignore h and k. And the way I do that is I like to box in the function but not include the h or the k inside the function. I hope everybody follows along with me here. Now, the h value is the value that's being with the x on the exponent position. Obviously, there is no x plus 3 on the exponent. There is no x minus 2 on the exponent. It's just x. So there is no h value. And if you notice, none of these questions have an h value. Okay. And once again, an h value is really a left or right shift. A k value is an up or down shift. But anyway, the first step is to ignore h and k, box in your function, and make a xy table for that boxed in function. This is what we call the parent graph, but we're including the a value of 3. Again, a is just the number, it's 3. B is the base, which is the growth factor, which is 2. There is no h, and the k value happens to be negative 9. Now, when you make an xy table, it's very important that we use consecutive integer inputs. What the heck is that? Numbers that are in order. Okay, so let's start. If you want to start with 0, put 0 in the middle. Okay, put 0 in the middle. Then you can put 1, 2, 3, and going in the opposite direction, negative 1, negative 2, negative 3. That's what we call consecutive integer inputs. All right, they're in order. Negative 3, negative 2, negative 1, 0, 1, 2, 3. They're in order. Now, the reason why we put these inputs in order is because when we start calculating the outputs by plugging these in one at a time, we will be able to see a pattern on those outputs. They will be growing. It's an exponential growth function. They're going to be growing by this factor of 2. Again, b is the base, b is the growth factor. So let's start by plugging in the easiest input. What's the easiest number to plug in? 0. If you plug in 0 right up here, it'll be 2 to the 0 power. Again, we're ignoring the minus 9. Let me actually do this. Let me put a box right there. We're going to ignore that minus 9 for a little while. So when I do plug in 0 right in there, what's 2 to the 0? 1. Anything to the 0 power is 1. So when I have 2 to the 0, that's 1, and then 1 times 3 is 3. So when I plug in 0, I get out a 3. Ladies and gentlemen, let's write that down. I plug in 0, I get out a 3. Does everybody understand the math that I did right there? Okay, so you could do that same exact math if you wanted to. You could plug in a 1. Should we do that just for fun? Yeah. Okay, what's 2 to the 1 power? 2. And what is 2 times 3? 6. So you could do what we just did right there to get out a 6 when you plug in a 1. But it's easier if you understand that the b is the growth factor or the decay factor. But in this case, it's a growth factor. Now, what does that mean? It's going to be growing by 2. So once you have one output, you don't need to do all that math again. You could just go to that output, if you did it right, that is. And you could go to that output and make it grow by 2. Now, if it would have been a 3 right there, you'd make it grow by 3, multiply by 3. If it would have been a 4, you'd multiply by 4. But it's a 2, so 3 times 2 is 6. So the next one is pretty easy. What's the next one going to be? 12, right? Simple. And the next one? 24. You have to multiply it by 2. The growth factor is 2. Does that make sense? Yes. Now, we're not even going to be using the 212 because 212 is off the graph. I mean, you could if you want to put a dot out there. And you're definitely not going to be using 324. It's way off the graph. Now, the only reason why we're able to use the growth factor of 2 is because the inputs were in order, right? I mean, you didn't have to use the growth factor of 2. Bless you. You could have plugged in 3 and said, okay, what is 2 to the third? Oh, 2 times 2 times 2, that's 8. 8 times 3 is 24. Yeah, input 3 gives the output 24. But it's easier to just get one simple output and then modify that output according to the growth factor. Times 2 is 6, times 2 is 12, times 2 is 24. Now, backwards, you wouldn't be multiplying by 2, you'd be what? Dividing by 2, right? If you're multiplying by 2 going this way, backwards would be dividing by 2. But you know what? Let's use the word multiply going backwards as well. So if I have 24, instead of saying divided by 2, I'm going to say multiply it by half. Because 24 times half is 12. And 12 times 1 half is 6. And 6 times 1 half is 3. I think we all agree that dividing by 2 is the same thing as multiplying by half, right? Okay, so if I say 24 times half, it's 12, times 1 half, it's 6, times 1 half, it's 3. What's 3 times 1 half? If you don't know it right off the top of your head, go ahead and write it down. What is 3 times 1 half? Put the 3 over 1, that becomes 3 over 2, right? So it's 3 halves. And now to get to the next one, what's 3 halves times half again? What do I get on the next one?
6 halves.
What is 3 halves times another half? Let me write it out if you need to. 3 halves times another half.
3 halves, 6 fourths.
3 fourths. 3 fourths. And how about 3 fourths times another half? 3 eighths. And as you could see, the numerator is always going to be 3 if you keep multiplying it by half going on the way up, right? Make sense? So what is happening, 3 halves, that's really 1.5. You know what, you could even write this down just so we can get a better understanding of this. It's really, 3 halves is really 1.5, 1.5. 3 fourths is really 0.75. 3 eighths, I don't know, let me get a calculator. 3 on the calculator divided by 8 is 0.375. 0.375. 0.375 is what I should have written. Let me write that down. Sorry. 0.3. I'll just leave it 0.37, even though it's 375. But what do you notice about these values as we go in the negative direction? Is it getting bigger or is it getting smaller?
It's getting smaller.
Smaller. So 1.5, 0.75, 0.37. It's going to get smaller and smaller. It is approaching what? 0. It's approaching 0. Okay, maybe you can't see that just by looking at the numbers. Let's graph what we have so far. So everybody, let's graph these coordinates to this parent graph. Remember, this is not our final graph because our final graph has to involve that -9 right there. So this is not our final graph. This is just our parent graph. Let's graph our parent graph right now. Let's start with the simple coordinate of 0, 3. 0 on the x, 3 on the y. 1, 2, 3. It's right here. Let's go to the next one. 1, 6. 1 on the x, 6 on the y. You end up right there. If you go to 2, 12, you're going to be off the graph. But you know what? I'm going to do it anyway. I'm going to go 2 on the x. 1, 2, 12, here's 10, 11, 12 on the y. Are you with me?
Yes, sir.
Now let's go to the negative direction. Let's go with negative 1 on the x and then 1.5. Okay, let's do that. Check this out. Negative 1 on the x and then 1 and then halfway. So it's going to be between the 1 and the 2. Everybody put a dot at 1.5 right there. At 1.5 right there. It's halfway. So again, let me show you. Negative 1 and then negative 1.5. Here's 2, here's 1, here's 1.5. Are you with me? Okay, now let's go to the next one. The next one is negative 2 and 0.75. Okay, so watch this. Negative 2 on the x, here's negative 1, negative 2, and then 0.75, that's 75% of the way up. It's 3/4 of the way up. It's not even to 1, it's 3/4, it's 0.75. So it's definitely more than half. but it's not completely to 1. So you're going to be around right here, 0.75. Now, if you go to the next one, -3 on the x, and then 0.37, is this more or less than half? Is this more or less than half? It's less than half, right? 0.37 is less than 0.5. 37 cents is less than 50 cents. So let's go -3 on the x, and we don't even get to half. It's less than half. So we go -1, -2, -3, and then not even halfway. It's less than half. So we need to put that dot right here, less than half. And it keeps getting smaller and smaller and smaller, approaching 0, right? So check this out. Smaller, smaller, smaller. At this point, it looks like you're drawing dots on the x-axis itself. But we know we never actually touch. We just infinitely approach, going from right to left. It infinitely approaches the y value of 0. Anyway, that is our parent graph. We are not going to actually draw a line and put arrows on it. We're not going to do that. Why not? Because I need to actually shift. Oh man, that didn't work out the way I wanted it to. So we're going to shift every single one of these coordinates 9 units down because it's a -9. So you're going to take this coordinate that's way up here at the y value of 12, and you're going to move it down 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9 down here. So let's put a dot right there. Okay, and then we're going to move this next one 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Putting a dot right there. 1, 2, 3, 4. Right there. And then we're going to move the other coordinate, this one, 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And you know what? Let's jump to our asymptote. The original parent asymptote was right here on the x-axis itself. If we move that down 9 units, from here down 9 units, you end up right here at this asymptote. That way it'll help us understand what we're infinitely approaching. We're going to be infinitely approaching -9. But let's continue to move all these other coordinates down, guys. Like, what do I mean by that? This one right here, I want to move it 9 units down, and it'll end up right here, 9 units down at the halfway point. Or not halfway, at the 3/4 of the way point. I'm sorry. Let me do that again. Right about there. So as you can see, from here we went down 1, 2, 3, all the way down here. That's 9 units down. This one that's almost at the y value of 1, it's going to go 9 units down. So it's going to be right here, almost at the y value of 8, so down here. This is probably one of the harder ones since it's the last one on the homework. But anyways, we know that it infinitely approaches that asymptote. And then you draw your graph, you draw a line through all those shifted points, put an arrow on it, and that's your final graph. What you need to do is go to that first graph and put 2 x's on it. That way I don't think that that's your actual graph, because the original one was the parent graph. The one that got shifted 9 units down, that's the one we want to represent. Now, there are other questions that we need to add. Oh, are you serious? So, what we need to do is answer the other questions, as in, what is our domain of this red graph? The domain are your x values. And this red graph does go to the left forever, and it goes to the right forever. Even though it looks like it goes up, it does go up, but it'll never go straight up where it doesn't exist over here. In other words, you could plug in, if you plug in a 0, plug in a 0, you get out that negative value right there. If you plug in a 1, you're going to get out -3. If you plug in a 2, you're going to get out +3, and so on and so on. So what could you plug in? You could plug in any numbers you want. So the domain is x equals all real numbers. Because you could plug in any number you want for x. You could plug in -1,000 if you wanted to. You could plug in -10. You could plug in +10. Plugging in +10 is going to give you an answer that's way up off the graph. But you could plug in any numbers you want. Visually, it does go to the left forever. It does go to the right forever. Even though it goes up, it still goes to the right forever. So the domain is x equals all real numbers. When we talk about the range, your range are going to be your y values. And the graph, y values are up and down. This whole red graph, it's either above a certain value or below a certain value. And to be more specific, it's going to be either above your asymptote or below your asymptote. If you take a look at your notes from last week, your asymptote is y equals k. So if you look up at the original graph, the k value is -9. So your asymptote is the line y equals -9. Okay? Now the line y equals -9 is a horizontal line at -9. And that is what your graph will infinitely approach but never actually touch. That's what an asymptote is. It's the line that your graph will infinitely approach but never actually touch. So your range is either above this asymptote value of -9 or below the asymptote value of -9. So tell me, is this red graph above or below the asymptote value of -9? Does anybody know if it's above or below the -9?
-9?
Yeah. Is anybody paying attention? Is it above or below the -9? It's above. So how do we represent that in terms of an inequality? Y is what?
Y is
Greater than -9. Okay. So your asymptote's -9 and your graph is clearly above -9. It never touches -9, it's above -9. It's not below -9. Sometimes it is below. You would put less than if that were the case. But it's above -9. So this is one of the hardest questions that there are on the homework. I hope you guys understand it. Please watch the previous videos if you need help.